if I could recall this thing, okay, we had 2 points of these points of intersection. The graph were to be equated. So we had half, I believe it was an x squared. Yeah, and then it was equals to negative, I'll put it as -1 right at the top, divided by x plus 1, x plus 1, x plus 1 plus 1, x plus 1 plus 1. All right, so one thing, I can multiply by the 2 to clear up denominator. I know last time I didn't multiply by 2, I know that. So we got x squared equals to -2 all over x plus 1, and then it will be plus 2. Next, I'm going to multiply by x plus 1 at the bottom. So I have x squared multiplied by x plus the 1 equals to -2 plus 2 into x plus 1. All right, bring to the left. I have x squared. I'm going to keep that in brackets. And then x plus 1. If I can bring that one, it was -2 plus 2x plus the 2. This and that cancel. So this can come over there. So I've got x squared into x plus 1 minus 2x equals to 0. Well, I can multiply inside or pull out x as a common vector. If I pull x as a common vector, I've got x. Open the brackets. This one will be left as just x times that bracket, x plus 1, and there it will be minus the 2. There we go. So one of the values, I'm going to have x equals to 0, or this one here, which is basically x into x plus 1 minus 2 equals to 0. It's not even factorized, so it's coming up. We're continuing with it. So I'm going to multiply into, so that I've got x squared plus x minus 2 equals to 0. Then I factorize. I've got x into x. The factors is 2 and 1 minus here it's a plus, close parenthesis equals to 0. Then I also have x equals to 1, or the other one would be x equals to -2. All right, so let's work with A first. Let's see, where is it located? A is far left, 3 points of intersection. B, original, and also A. A must be the -1. It will be -2, semicolon, to get the y. Well, here's an equation in a red box. I put a -2, I square it is a 4. Half of 4 is +2. So I would insert 2 here. All right, let's go for B. Point B, let's locate it, is the one that is more positive, greater than 0, so that will be the 1. Put 1 squared here is 1 times half, it's going to be a half. So that one. So those are the coordinates there. Then I can give them the 0, 1, 0, semicolon, and 0. Good. Now, next point. Find the graph here. This one, I think I did. This part I did. I remember this portion. I transposed the other part. I said g of x must be greater than f of x. I had the asymptotes. Actually, you can do this by using inequality. Last time I drew dotted lines. Well, let me steal it for you. I'm a nice guy. I want to show you different methods. Different methods. Sometimes you don't even need that thing. Okay, you don't even need to go to the graph. You say, okay, what is g of x? It's minus 1 all over x plus 1 plus 1. You are basically repeating this. You're going to end up with the same thing, but with greater than, less than. I just want to prove the point. I said it's greater than half x squared. So I multiply by positive 2. The sign does not change. So it's minus 2 all over x plus 1. And then it will be plus 2 greater than x squared. You can't multiply by x plus 1 because you don't know whether it's positive or negative. You actually bring everything to one side. I'm going to take that, bring it to this side. Transposing. So I've got 0, it's less than x squared. That minus 2 changes to a plus. So it's going to be plus 2 all over x plus 1. That positive 2 becomes the minus 2. I just do LCD here. So 0 is less than. Exactly what we had on the other side is going to show up. You will see it. All right, this is over 1. This is over 1. Since you know LCD, it will be x plus 1. The x plus 1 will times the x squared. I'm just keeping as it is as x squared, x plus 1. And then here it goes 1 time, so it will be plus 2. Here it goes x plus 1 will times the minus 2. So minus 2 into x plus 1. I'm just showing you, sometimes they say, you don't have to show them this working out, but I'm showing you how to do it with the working out. So I'll have 0, it's less than, well, I can multiply inside there. I've got x to the 3 plus the x squared plus the 2 minus 2x and then minus the 2. And then it will be all over x plus 1. You can see that and that cancel out. And then the numerator, I've got 0 is less than, I've got x to the 3 plus x squared minus the 2 all over x plus 1. Well, I can write this sign on this side here if I want to. Here's how it's going to look like. That sign, it's opening its mouth to eat the 0. It's like a Pac-Man. So that means if I were to put the 0 on the other side, you can see the arrow is pointing on the equation. So if I put it on the other side, the arrow points the equation, the 0 is to be eaten still. It's the same thing. It's because you love it when it's on this side. The top must be factorized. I pull out a common factor of x into x squared plus, wait a minute, I hope I didn't miss anything. I think I did not miss anything here. Okay, there it is. It's minus 2x. Minus 2x, yeah. All right, so there we go. And it's going to be 1. I'm pulling out x, z squared, so it's going to be x. And then minus the 2. All right, all over. You don't need to do this, but I'm showing you it's solvable. All right, then I can still factorize the other geezer there at the top. So I can write it as x into x. 1 is 2, 1 is 1, the same number we had before. You got a plus 2 and a minus 1. And then all over at the bottom, you've got x plus 1. I'm going to parenthesize that. Then you've got less than 0. All right. Because you guys, they make you do parabola. So this is way more than parabola. So when I draw my critical values, all right, so I know when I solve this one, the first one here, I'm going to get 0. I'm just putting it above. When I solve x minus 1, I'm going to get a 1. When I solve x plus 2, I get a minus 2. When I solve x plus 1, I get a minus 1. So if I write my critical values in order, it's minus 2, semicolon, minus 1. I got 0, semicolon. I've got 1. 1, 2, 3, 4 values. Yes. Then we use a number line. We put them as they appear. We say minus 2, minus 1. We say 0. We put a 1. We even put an arrow there. Put an arrow there. And then we put an X. So we test the sign. You guys, you just draw parabola. I'm going to test a number beyond 1. I'm going to put like 2 or 3 or 4 or 100 or 10,000. That's all. So if I put a 10,000 here, by the first X, I know it's a positive sign. And then your 10,000 here minus 1 is going to give me a negative sign. If I put a 10,000 there, I end up with a positive. At the bottom is going to be plus. So when I investigate the sign, I've got a positive times negative, which is negative, times positive is negative. At the top, I've got negative divided by positive. I end up with a negative. So that's all I needed to know. The sign beyond 1, it's positive. When I skip that, it changes. Here, wait a minute, let me back off here, sorry. The sign beyond, it was negative. When we skip, it becomes a plus, and then negative, and then plus, then negative. Then this sign says less than. Less than means minus. The minus is here, another one is here, another one is here. The first minus here tells you, let's write it in white and put it in a box. So it's going to be x is less than negative 2. We boxanize that. Then we can also say, oh, the next minus is between minus 1 and 0. So I'll say minus 1 less than x less than 0. That's the second solution. And then the next one, it's beyond the 1. So it's going to be x is greater than 1, which is that one there. Okay. So in the box, those are your signs. So when you answer this question, you don't even need to show the calculation. You show what's in the box. Now, on the same note, you don't have to put equals. On the same note, here I go. I come back where I want the graph of G. It's above F. Normally we do this. I said, okay, I need where the two graphs intersect, here by the dot, here by the 0, here by the B, and also we need to take the asymptote, which is just there. So then we draw vertical lines. I'm going to draw a vertical line there, the red one there. And then I need to draw the next one, because that's how we normally do it. We like, okay, but this one is an asymptote. And then we place another line there. Okay, let me put it there. And then I place another line there. Put it there. All right, so the graph that we're looking for is the hyperbola. I look on the left-hand side of the red line. Where is the hyperbola? Above the other one. Well, it's below because it's this blue part. That's not what I want. That's not what I want. What I want, let me make sure I'm correct. Where did he say? Oh, yeah. Yeah, G, it's above. So where is above? Is here. It's here by the blue. Where is above again? How about here? No, it's not. How about here? Yeah. Here it's above. There we go. And then the question says, is there any other place where it is above? You see, then you're going to have to use these values here. You see, because this one here, I think by 1 it was -2. We had -2 there. And then by the asymptote, because it's horizontal, it's vertical, is that -1. It's by -1. So the first one, I'm going to write -2 less than x minus -1. Let me see that. Why it seems like, where did you have that 0 there? That means I was looking at the other graph, maybe. Okay. There's that. All right, fine. I'll just double check that. All right. That's where the G is above, between -2 and that. And then here, between -1 and 0, the other one is big. Then here, between 0 and I think 1, the other one is 0, less than x, less than 1. So the black is g of x greater than f of x. Okay, let's do the less than. The less than is this one, which is going to be x is less than -2. Whatever we did not use. And then the other one, it was between -1 and 0. So that would have been -1 less than x less than the 0. Let's see, was it here? Yeah. Then the other one was here, greater than 1, where it's below. We're going to say x is greater than 1. The red one, it's where g of x is less than the f of x. All right, so let me look at here. what I gave you. First, I gave you x is less than minus 2, which was that one. And then I gave you minus 1 and 0, which was that one. And then greater than 1, where is it? This one. That was for g of x to be above. Now, what's perplexing? I'm supposed to be giving you, oh yeah, that was g of x to be less than, I'm sorry, this red one. It's less than. The black one, it's above. The black one, it's actually our answer. Did I need to do something here? All right, I put a positive there. It's a minus. No, it's me here. This was plus here because I'm putting like a big number, bigger than 1. That means 2 minus 1 is a positive here. That sign there. So I made a glitch. So it was supposed to be plus at the end, plus, meaning my answers will be by the positive here. Okay, let's surround them with white. Positive here, positive there. Those two between minus 1, minus 2, minus 1. Yeah, which is that one. The other one, 0 and 1, which is there, 0 and 1. Yeah, that was just minor. But it's good. I showed you both greater than and equals to. So what I'm saying, you can do this, which is quicker if you understand it, or you can do this. But when you do this, you don't show calculation. You give them the answers. Okay, I would have said the box, but it will be just these ones, the end results. All right, so far so good. All right, so now let's do the last part of it. The last part of this, it was, we were supposed to get something here. Yeah. The inverse thereof. We were to do the inverse thereof. Now let's put the inverse of the thing. All right. So they say that determine the inverse of g of x in that form. All right. Yeah, now I feel like we did everything. We just needed to swap x and y because here's an equation, that one. So let me write it. G of x, we actually had minus 1 all over x plus 1 and then plus 1. We need to swap x and y, and then that means this becomes x equals to minus 1 all over the y plus 1 plus the 1. I would multiply or just transpose the 1 that side. So it's x minus 1. There are many methods we can do it. Then minus 1 over y plus 1. Because I did it, this one is over 1. I'm going to write this upside down, the box, and also the other box. That's quicker. So it's 1 over x minus 1 equals to y plus 1 all over minus 1. Multiply that side by negative 1, so you're going to have negative 1 all over x minus 1. X minus 1 equals to y plus 1. Now I can bring the 1 over, then the story will be done. So y equals to negative 1 all over x minus 1 minus 1. So that will be the inverse thereof. That was good. All right, remember if it cuts you out, jump